This question looks at how to resolve a force, and it's a question that's quite often dreaded by pupils. So let's have a look at the question and break it down. It says here we've got an aeroplane and we've got a glider. The tension force in the cable can be resolved into a horizontal component and a vertical component. So a horizontal component is one like a y-axis in a graph, which goes down as follows, and a vertical component is one like an x-axis that goes across. And we have information that tells us that the tension is 2000 newtons at an angle of 20 degrees. And we've got to draw a vector diagram. So we've got to think, first of all, we've got 2000 newtons here. This has to be to scale. It's really important that in these exams, you're going to have a protractor and a ruler. You need a protractor for the angle and a ruler to draw a nice straight line. But we're not going to have to do it in 2000 centimetres. So we'll whittle it down, and let's say that we're going to have ours at 20 centimetres. So 20 centimetres will equal 2000 newtons. And then just so we get the scale right in our heads, then 1 centimetre is going to be equal to 100 newtons. So we've got to draw an angle of 20 degrees. There's 20 degrees. A line that is worth 20 centimetres. You can just fit it on the screen here. And that's our axis here. And then what we've got to do is resolve it. And so by resolving, we've got to make it into, really, a right angled triangle. So on our horizontal axes, make sure we've got 0 degrees here, so your ruler is nice and straight. 4, 5. Take your time. It's really important to be as precise as possible. There we have it. So we're going to draw in our horizontal axes along the side. And we also want to draw in our vertical axes. Again, this one is going to be at 90 degrees. So at 90 degrees, there. Then all we have to do is measure it for the magnitude. So for the case of our horizontal axes, with your ruler, you'll see it goes through about 18.7. 18.7, which to our scale is going to be 1,870 newtons. Oh, that's what happened there. Our vertical axes, we're going to have to, again, carefully measure. Goes to, we see, 6.7. 6.7. So, that's centimetres, so 670 newtons. So our horizontal component is 1,870 newtons, and our vertical will be 670 newtons. I hope that's helped with resolving vectors.